Have you ever thought about how a place can be so hot you could literally fry an egg on a rock, but then just a few hours later it's so cold you could freeze water? Well, that is the daily drama of the desert. And today we are going to figure out the science behind this absolutely insane temperature swing.
Okay, so do me a favor, just for a second, when I say the word desert, what's the very first thing that pops into your head? I'm willing to bet it's not a snowy landscape, right? It's got to be that endless sand, a sun that just beats down on you, and heat. Just so much heat.
Exactly. It's that shimmering, almost liquid-looking heat you see rising off the ground. You know, the kind of intense, relentless heat that, even makes a camel look completely miserable. And that's really saying something, because they're built for this.
But, and this is where it gets really interesting, that blistering heat, that's only half the story. The desert is hiding a huge secret, a total plot twist that happens every single day, right after the sun sets.
And here is that paradox, right here. You can go from over 50 degrees Celsius, that's a scorching 122 Fahrenheit, during the day, to temperatures that actually dip below freezing at night. I mean, you literally go from roasting alive to desperately needing a thick blanket in just a handful of hours. So what is going on here?
Well, to crack this mystery, we need to talk about something you can't even see, Earth's invisible blanket. It's the one thing the desert is missing, and it changes everything.
First things first, let's get our definition straight. A desert isn't really about heat, it's all about dryness. Officially, any place that gets less than 250 millimeters of rain a year counts. And this leads to a pretty wild fact. The largest desert on our entire planet isn't the Sahara, it's Antarctica. The one thing they both have in common, a serious lack of moisture.
And that lack of moisture, that's the whole secret. You see, the humidity in the air, all that water vapor, it acts like a giant invisible blanket for our planet. It's a huge part of the natural greenhouse effect. During the day, sunlight passes through it, but at night it traps the heat rising from the ground, keeping us all from freezing. And that, right there, is the heart of the issue. Deserts, by their very nature, are incredibly dry. With almost zero water vapor in the air, they have no blanket. There's absolutely nothing there to hold on to the heat when the sun disappears. So, this missing blanket is what creates the entire daily cycle of the desert. It's why they roast by day and then get shockingly cold by night. It's a pretty simple two-step process, really. First, during the day, there are no clouds, no humidity to block the sun, so all of that solar energy just hammers the ground without anything getting in the way. And second, sand itself is terrible at holding heat. It gets super hot, super fast, but it has absolutely no ability to store that energy for later.
And how hot are we talking? Well, the surface of the sand can easily get over 50 degrees Celsius. Yeah, that's definitely hot enough to cook on, and for sure hot enough to seriously burn your feet if you were silly enough to walk around barefoot.
But the moment the sun goes down, the entire show flips into reverse. All that heat that the sand absorbed all day has to go somewhere. The scientific term for this is radiational cooling. A good way to think about it is like a hot frying pan you take off the stove. It cools down way faster than, say, a pot of hot water, because it just radiates all its heat right into the air. The desert is basically that frying pan, but on a colossal scale. And since there's no blanket, no clouds, no humidity to trap it, that heat doesn't just hang around. Nope, it radiates straight up and out, lost forever into the cold, vast emptiness of space. It's like it just vanishes.
And the result is just staggering. Just look at this. A daytime high of 40 degrees Celsius just plummets to below freezing at night. In places like the Gobi or the Atacama Desert, a temperature swing like this in less than 12 hours is completely normal. You go from sweating in a t-shirt to shivering in a winter coat.
So, you have to wonder, if the environment is this brutal, how does anything manage to survive out there? Well, it turns out the desert is home to some of the planet's most clever survival masters.
Seriously, how on earth does life cope with this daily roller coaster? Well, it's found some incredible workarounds. Take the fennec fox. It uses those huge ears like personal radiators to dump excess heat. The kangaroo rat just decides to skip daytime altogether, living in cool burrows and only coming out at night. Some snakes will actually dig down into the still warm sand at night just to stay insulated. And the classic cactus, it's basically a living water tank with a waxy coating to make sure not a single drop evaporates.
And what about people? We're pretty good adapters too. Traditional desert cultures built homes out of adobe clay, which is genius. It soaks up heat all day and then slowly releases it through the cold night, acting like a natural space heater. And even today, hyper-modern cities like Dubai use those same ancient ideas, just with fancy high-tech insulation and smart materials to do the job.
You know, this extreme environment doesn't just teach us about life on Earth. It also gives us a fascinating preview of what other worlds are like, and a pretty stark warning about our own.
Just think about Mars for a second. Mars is essentially a planet-sized superdesert. It has this incredibly thin atmosphere, which means, you guessed it, no thermal blanket. So just like our deserts, it gets kind of warm in the direct sun and then absolutely plummets to below -100 degrees Celsius at night. This is exactly why NASA uses places like Chile's Atacama Desert to test its Mars rovers. It is the closest thing we have to the real Martian environment right here on Earth.
There's this fantastic quote that says, "The desert is where Earth practices being another planet." I just love that. It really captures how alien and extreme these places are and why they're so important for science.
But that delicate, extreme rhythm, the one that life has spent thousands of years adapting to, is now in serious trouble. And the source of that trouble is us.
There are two big problems. First, climate change is making desert nights warmer. That critical cold snap that a lot of plants and animals need to trigger flowering or to reproduce, it's getting shorter and shorter. And second, as we build huge cities like Las Vegas or Dubai in the desert, the heat from all that concrete and the constant glow of artificial lights, well, they create a man-made blanket, messing up the natural cycle of dark and cold that the entire ecosystem relies on.
And in the end, the desert becomes a kind of test for all of us. It makes us ask a really important question. Are we going to learn to live in harmony with our planet's natural rhythms? Or are we just going to keep turning up the heat and flipping on the lights, breaking the ancient rules that allow these incredible, fragile places to even exist?